Hello everybody and welcome back to Can It Math! I'm your host, Algebra, and today we are talking about growth and decay. But we're missing something. We need our special guest. Give a round of applause to Sarah Harrison! Thank you. I'm so glad to be here. So, Sarah, how are you feeling about today? Well, I'm feeling pretty confident about this. How are you feeling today? Good, I'm glad to hear it. I'm doing well myself, thanks. Now, let's just jump straight into it. So, today you will have to be making a lot of graphs and there's a lot of writing involved. Are you up for the challenge? Yeah, I'm ready for the challenge. I think this will be fun. Good, let's get into it. So today, Sarah, in case you didn't know, we are talking about growth and decay. We have 3 main questions that have a bunch of sub-questions in between them. Are you ready for the task? Like I said earlier, Al, I'm super ready. Well then, let's jump right into it. Our first question says, a person comes to you and offers you a job working full-time every day for the month of April. She says she will pay you 1 penny for the first day, 2 pennies for the second day, 4 pennies for the third day, and 8 pennies for the fourth day, so on and so forth, and she doubles the pay every single day. So I guess our first question is, would you take the job? Would I take that job? I'm gonna have to go with yes, because I feel like eventually it'll keep adding up to more money. Okay, that's a good answer. How much will you make in the first week? Well, I've got my whiteboard here with me today. The first week, so if you add each of the days together, you will get $1.27. What is an equation that will tell how much you get paid on any given day? If the days equal n, then y will equal 2 to the n minus 1 over 100. How much will you have made after 2 weeks of work? If we do the same method we did earlier, just multiplying each day by 2 until we get to 14 days, we will have $163.83. Do you think the job is still worth it? I do think the job was still worth it. You know, as we've just shown, I'll have $163 by the end of 2 weeks, so a whole month? That's a lot of money. I mean, this might take a little bit of time, but can you please show us a calendar of the amount you will get paid every day? Of course. Let me just whip it up real quick, and here we go. Here is the month of April with all the dollar amounts in each day. Now, can you please create a graph showing your pay for the first week? Yeah, here it is. So if you look at the graph, you can see that the rate of pay steadily increases throughout the week. So what is your final decision on accepting this job? From the data I've shown, this is such a profitable job. I will have $5,368,702.12 by the end of 1 month. Alright. I see how it is. So that question was pretty easy, but now we have to get into some real math. So now we'll move on to the second question. If you take the last day's pay and put it into a savings account that pays, let's say, 3% interest, compounded quarterly, and if you leave it in there for 20 years, how much money will you have at the end of those 20 years? Okay, well, the formula for this is A equals P times 1 plus R over N to the NT. A is the ending amount, P is the starting amount, R is the interest in like a decimal form, N is the number of times compounded, and T is the time in years. So now we can just plug everything in. So the last day's pay was $5,368,702.12. Or excuse me, in 2 cents. I've been mispronouncing this whole time. Our interest, you said, was 3%, so that would be 0.03. And the number of times compounded was quarterly, so that just means 4 times a year. And you said 20 years. Plug all that in. Here's my work. And the final answer is $9,814,000.09. Could you please show us a graph of the first 5 years? Oh, okay. A graph of the first 5 years. Let me just, yeah, here we go. So this graph, as you can see, It shows the number of years on the x-axis, and on the y-axis shows how much money is in the account, starting at 5 million and going up to 6.5 million. And looking at this graph, you can see that it steadily increases for 3 years. Now, we have one last problem for you to solve today here on Can It Math? Depreciation is a decay in the value of an item. Our decay model is y equals c times 1 minus r to the t. Suppose you take the 23rd day's pay and buy a new car. Use this model to find the value of the car after 6 years if it depreciates at 15% per year. Okay, well, you said your model was, let's see, y equals c times 1 minus r to the t. So y is the total, c is the original, and t is the time. The 23rd day's pay was $41,943.04. So we just plug in our numbers like we did last time. So for the first year, y will equal $35,000, $35,651.68. Then I did the same thing for the other 5 years. I'm just going to show you my answers because you already saw my process for how I got them, and I don't want to write everything out again. Now I'd like you to make a graph. Yes, please make a graph and show it to the audience. Okay, Al. So here's the second graph, and then on the x-axis you can see the number of years, and on the y-axis you can see the money as it depreciates. It steadily decreases throughout the years. Alrighty, well that has been Can It Math with our guest star, Sarah Hansen. Thank you. And I'm Algebra. See you next week, ladies and gents.